Hello, I hope you're all having a good Monday. Since I can't be in class, I am video recording what I'd like for you to do this week. So please make sure you watch the entire video and pause it when it says to pause and do the work that I've indicated. So the first thing that you're going to be doing is we're going to talk about the homework for the week. So for this week, you need to make sure that you've completed all of the work listed in weeks 2 and 3 on the handout, on the yellow handout, okay? Let's take a look at week 4 right now. So week 4, you can see that in week 4, we have percents, decimals, and fractions. You'll have some notes on that later this week. Also, you have factors, multiples, prime factorization. So these pages that are indicated here are pages you should do out of the textbook. So last week you received 2 packets that are the next sections of the textbook. Please make sure that you find the pages in here. If you did not pick those up, you can also get this on Canvas under the arithmetic workbook. Okay. The second thing is you'll notice on your homework sheet that it also has 2 supplementary handouts indicated. These are found in your salmon packet. If you open your salmon packet to after the division of decimals, the next page says factors, multiples, prime factorization. This is the first one for the week, so I'm going to mark it week 4. That way we can remember it's due this week. If I turn the page, the back side of that is the remainder of that packet, so please mark that week 4. Okay. The next page says Intro to Percents. This is one that I'd like you to read this week, so write homework week 4 on the top of that page as well. And on the following pages, you have a page that says Intro to Percents and has some problems in it. Please mark week 4 on the top of that page as well. Okay. So that's my math homework for the week. My science homework, so remember you go online to the science textbook and you read the section and then you take notes on what you saw, what you read. So on my yellow handout it says that I should be doing chapters 37 through 39. So I'm going to look for chapter 37 through 39. You'll see a handout that looks like this. So each of the columns refers to one of the sections that you'll be reading. So please read chapter 37 and take notes here, 38 and take notes here, and 39 and take notes there. The next section you will need to read, so I'm going to mark that page homework for week 4 so that I remember I need to do that. The next thing that you're going to have to do is chapter 48 to 49. This should look familiar. We did chapter 46 and 47 last week. So for chapter 48 and 49, I'm going to put homework for week 4 so that I remember that I need to do those 2 for week 4. Hopefully that makes sense. The last thing that you need to do is take notes, watch the video, and read chapter 50. So if you turn the page from where we just were, you'll see that there's one on the back. That's 50, so that's for week 4 as well. Now, there's not enough room on this handout to do the outlines indicated, so you will have to attach a scratch piece of paper. Hopefully there's no questions. If you do have a question, please either email me or rewind the video and take a look. A few other things you should be working at this week. If you didn't finish the calculations from the Domino Lab that we did on Thursday, please make sure that you do that today. And the other thing you should be making sure that you're getting done this week is working on your project. You should all be at the point where you have your experiments settled out and you're collecting data. So please make sure to collect data This will all be due on August 10th, so make sure that you're collecting your data. Remember, more trials is better than less trials. Okay, so what we're going to be doing today is we're going to be working a little bit with operations with decimals. We're going to work on kinetic and potential energy, and we're also going to be working on powers of 10. So let me just grab a few things here, and then we'll talk about that. Okay, so the first thing I'm going to be having you take a look at is the order of operations of decimals. So in the handouts I gave you last week, it looks like this. Okay. We're going to be working from this sheet right now. So as we work from this sheet, let's just review the rules that we learned last week. So we're going to use the method that's called GEMS to be working through this. And GEMS, if you remember, the G stands for grouping symbol. And by the way, you should be using your notebooks. You should have a page of your notebook open. You can call it Order of Operations. You should have today's date. And you should include these notes on the correct page number. Okay. So grouping symbols is for G, and grouping symbols include parentheses, brackets, and braces, and anything underneath a square root sign. The E is for exponents. The M is for multiply and divide, left to right. Please remember this is one step and we do it left to right. And the last one is subtract and add. Again, we do left to right. That means that if there's more than one, there's addition and subtraction in the same problem. You start with whatever's furthest to the right and you work your way, you start with whatever's closest to the left and you work your way to the right. Okay, let's look at a problem and see how we would do it. So let's look at number 1 together. 9.4 plus parentheses 1.5 plus 6.5 parentheses times 6.7 minus 4.5. Okay. When I look at this, the first thing I see is that there are parentheses. Since that is a grouping symbol, I'm going to start there. I'm going to show my work on the sideline so that I can remember the rules of decimals. So when I'm adding decimals, I'm lining up my decimal places. So here 1.5 plus 6.5, I'm making sure my decimals are aligned and adding. 5 and 5 is 10, put down the 0, carry the 1. My decimal goes straight down. 1 plus 1 plus 6 equals 8. So this information in parentheses simplifies to 8. It is important to remember to show all steps because I will be looking for all steps on the quizzes and the tests. And also all steps are important because it's a way to track your work. Okay, now that I have that, I'm going to just copy down the rest of the problem. Now I'm done with my parentheses, and my next step is going to be what? Hopefully, you're saying that I'm going to multiply next, because there are no exponents in this problem. So when I go ahead and I'm going to multiply, I'm going to be doing 8 times 6.7. 7 times 8 is 56, put down the 6, carry the 5, and 8 times 6 is 48. 48 plus 5 is 53. Okay, where does my decimal point go here? It goes one place over because there's one decimal place. Okay, at this this point, I'm going to replace this multiplication with the answer I just got, 53 and 6/10. And I'm going to copy the rest of the problem down. So now my problem just says 4.9 plus 53.6 minus 4.5, right? My next step then is I'm going to go through and I'm going to add and subtract left to right. So notice that's different than the order it says here, but these two go together in the same step. So I'm going to start with adding 9.4 and 53.6. So 9.4 plus 53.6, I'm lining up my decimal points because that's what I do when I add. And 4 plus 6 is 10, put down the 0, carry the 1. 9 plus 3 plus 1 is 13, put down a 3, carry the 1. 5 plus 1 is 6. And my decimal I bring straight down. So my final answer, I guess it's not my final answer, but my answer here is 63. If I bring down my next step, I have 63 minus 4.5. When I'm subtracting 63 minus 4.5, again I'm lining up my decimal point. My decimal goes straight down. I'm going to have to borrow here. I can't do 0 minus 5, so it becomes 10, and the 3 becomes a 2. So 10 minus 5 is 5. 2 minus 4 I can't do. I borrow from the 6. It becomes a 5. And now I have 12 minus 4, which is 8. And then I have the 5 that I just bring down. So my final answer here, when all is said and done, is 58.5. Does that make sense? Hopefully it does. I'm going to give you a few minutes. You can pause the video. You can continue working through some problems on here, making sure to use the order of operations and using the rules of decimals. Okay, we had a good review of that right now, so go ahead and pause the video and do this work. The answers are on Canvas, so you will need to check your answers on Canvas. Okay, the next thing we're going to be looking at now, which is going to be the next section in your notebook, is looking at multiplying and dividing by powers of 10. Okay, so we're going to label the next section of our notebook, multiplying and dividing by powers of 10. And what I mean by powers of 10 is 10 times the number, or 100 times the number, or 1,000 times the number. So powers of 10 are numbers that end in zeros. Does that make sense? Okay, so when we multiply or divide by numbers that end in zeros, there are some special rules that we can use. So first we're going to look at when you multiply by powers of 10. And I'm just pulling out my notes from last term to make sure I don't forget anything. So if I'm multiplying by a power of 10, let's say I'm taking the number 5 times 10. Basically what I do is I multiply my 5 times my 1, and then I add the number of zeros. Right? So 5 times 10 would be 50. We've been doing that for a while, so that shouldn't be anything new. We can also look at this a different way, though. We can look at this that if 5 times 10, what we're actually doing is removing the decimal point in the 5. So instead of 5, there's 1 0 in 10. So we're going to move our decimal point one place to the right. So the 5 becomes a 50. Does that make sense? 5 times 10, I have 1 0, so I move my decimal place 1 to the right. So the rule that I can use with multiplication of powers of 10 is that I move my decimal to the right the same number of places as there are zeros. So here, in this example, I had 1 0, so I moved my decimal place 1 to the right. We're going to try a couple more right now. So, if I have the number 3.26 times 10, my decimal point is here. There's 1 0 in my 10, so that means I need to move my decimal 1 point to the right. So my answer would be 32.6. If I were to do my multiplication out, I would come up with the same answer. Oops, I put one too many zeros. Let me try that again. 32.6 or 3.26 times 10. Here we go. Put a 0, because 0 times 6 is 0, 0 times 2 is 0, 0 times 3 is 0. Now 1 times 6 is 6, 1 times 2 is 2, 1 times 3 is 3. My decimal goes 2 places over, so I'm going to put it between the 2 and the 6. So what if I'm multiplying by a larger number, such as 1,000? So if I have 45.7 times 1,000. Notice there's 3 zeros here, so that means my decimal point is going to move 3 zeros. Since I'm multiplying, it's going to be 3 zeros to the right. I do not have numbers in these places, so because of that, I need to put in placeholding zeros. So I'm going to add 2 zeros to my number to get 45,700. I'd like you to try a couple of these on your own. Let's try 5 48 times 1,000 and 46.1 times 100. Go ahead and work through these for a second, and when you're done, we'll talk through them. Okay, hopefully what you did was you moved the decimal point in this first one 3 places over to get 5,480. And in the second one, hopefully you moved your decimal 2 places over to get 4,610. That's what you got. Very good. You're almost ready to do the worksheet. We just need to first talk about division by powers of 10. Okay. So with multiplication, the rule was we move our decimal to the right. We're getting bigger with our numbers, right? When we're dividing, it's slightly different rule. When we're dividing, we're going to move the decimal to the left, because what's happening is our number is getting smaller. And so we move the decimal to the left the same numbers of places as there are zeros. Okay, so please get those notes down, and we're going to try a couple right now. The first one we're going to try is if I have 3.4 divided by 1,000. 3.4 divided by 1,000. If I have 3.4 divided by 1,000, I'm dividing. 1,000 has 3 zeros in it, so I'm going to move my decimal 3 places to the left. to make it a smaller number, right? Moving it 3 places to the left, we'll put it here. What I need to do is fill those spaces with zeros. So I have 0.0034. Okay. Does that make sense? Try another one together. I'm going to try the number 74.14 divided by 100. Okay. In my number 100, there are 2 zeros. So you're probably guessing I'm going to move my decimal point 2 places. 2 places to the left because I'm dividing. So if I move the decimal 2 places to the left, I get 0.7414. Let's do 2 more on your own, and then we'll move on to the next topic. Okay, so here are the 2 I'd like you to try. I'd like you to try 5.43 divided by 100, and I'd like you to try 0.01 divided by 10. Take a few minutes, do this while the video is paused. Okay, let's take a look at what you came up with. If you divided 5.43 by 100, you have 2 zeros here. That means I need to move my decimal 2 places to the right. To the left. I'm dividing, so I move it to the left. When I move it 2 places to the left, I end up with the answer 0.0543. Hopefully that's what you got. Let's do the next one for you. If I have 0.01 divided by 10, I have 1 0. That means I'm moving my decimal point 1 place. I'm moving it to the left because I'm getting smaller. Moving it to the left means that I'm going to have 0.001. Okay. If you're feeling good about that, then great. If you're feeling good about it, it's time to just pause the video and work through the handout. Multiply by positive power of 10, and the back side, multiply and divide by positive powers of 10. So take a few minutes to do that, then check your answers on Canvas. Okay, our next topic for today is going to be scientific notation. If you recall, back in week 2, you had a handout on a supplemental handout on scientific notation that we never talked about. So I want to come back and talk about that now, and then I want you to go back to week 2 and make sure that you're understanding scientific notation. Okay, so to do this, I want to take you to a website first. So you're just going to be patient with me as I pull up the website. And hopefully you're able to see the website fairly well. Starting to come up. Good, you can see it pretty well from there. You'll get the idea of it anyhow. I'm going to be talking very loud so that hopefully you'll still be able to hear me in this recording. On this website, I'm going to choose English because I want my language to be English. And here I'm going to push start so that I can see this image. So what this website does is it shows you different scales. So you can look over here and see that it says 10 to the 0 power. I'm going to scroll smaller and bigger by moving this cursor to the right and to the left. And as I do that, you're going to see items that are larger and smaller. you're going to notice that this value changes. So I'm going to go ahead and I'm going to do some scrolling. First, I'm going to make objects larger. So now we're looking at larger objects. You'll notice that now I have 10 to the power of 1.1. That is actually saying that it's about 10 meters in length. Okay. Now we're going to keep moving. Okay. Now we're looking at things that are about 10 to the 5th power. So that means 10 times 10 times 10 times 10, 5 tens, right? Multiply 10 by itself 5 times. So when I'm looking at that, I'm seeing things the size of Rhode Island, the size of moons of different planets. This website, which is called Scale of the Universe, takes us to very large things and then very small things. So I'm going to show you how large they get, just for fun. So right now, we're out of the galaxy. We're at galaxies far, far away. And we can see that the universe would be represented by 10 to the 27th power, meaning 10 with 27 zeros following it. That's a really big number, right? You wouldn't want to have to count all those zeros out. We can also do the reverse and find 10 to very small power. So I'll go back around the 1 meter mark. So now we're in measurements of things that we know. So here's our 1 meter, a little bit less than 1 meter. I'm going to go smaller. You'll see that we passed the hummingbird and the shrew. Okay, so now we see measurements like 10 to the negative second. Negative second is talking about a number like 1 over 10 times 10. So that's 1 over 100 that we'd be looking at there. So 1/100th of a meter, which, if you remember, 1/100th of a meter is about a centimeter, right? So that's about what we're calling an ant or a sunflower seed. I'll scroll to the smaller things just so that you can see what would be even smaller. So now we're seeing 10 to the negative 8. So that's 1 with 8 zeros after it. And here we're looking at nano. So maybe you've heard of nanotechnology. And we're also looking at phospholipids. So these are what the fats that are in your body look like. Also atoms, right? So you can see that we're getting very small. For fun, I'm taking you down to the smaller measurements, but realize you don't really need to know much about this. So the point of this whole thing is that we want to talk about scientific notation today. Okay. When I talk about scientific notation, I'm talking about a way to represent really big numbers and really small numbers. You wouldn't want to have to write out 1 with 27 zeros. No one would know what that number meant, and you'd likely lose count of zeros at some point, right? So if you have big numbers or small numbers, scientific notation is very helpful. So make sure that you label a section of your notebook, scientific notation. Make sure you put the correct page number corresponding to where you're going to take these notes. Okay, so what scientific notation is it is a way to write really big and really small numbers. So when I'm writing really big or really small numbers, I use this form. So such as 7.8 times 10 to the 5th power. This is a form that's called scientific notation. The parts of scientific notation are right here. You have your number. The number is a decimal, and there's always one digit in front of the decimal point. The second part here is the times 10. Every scientific notation has that piece in it. And then there's an exponent. What this number actually means is that we're going to move our decimal point 5 places to the right. So you remember when we were multiplying by powers of 10? We'd move our decimal point to the right. So that's what we're going to do here. We're moving it 5 places to the right. So if we want to write what is called standard notation, we're going to take that decimal point and we're going to move it 5 places over. 1, 2, 3, 4, 5. Put our decimal there instead. As with everything else, we're putting in those zeros that we've taken out. So my answer would be 780,000 in standard notation. Hopefully that's making a little sense. We're going to try some more. First, though, I want to write out the rules for you. So if I'm writing in scientific notation, I look at the exponent. Okay. If it is positive, you move to the right. You move the same number of spaces as the number indicates. So here we had a 5, which meant that we moved 5 places to the right. So let's look at this example, 6.452 times 10 to the 7th. So since my exponent is a positive 7, I'm going to move my decimal point 7 places over. So that's 1, 2, 3, 4, 5, 6, 7. Well, in order to make this work, I have to fill in zeros here. So I'm going to rewrite my number, 6.452, with 4 zeros after it. Once I put my commas in, I can see a little bit better what that number actually represents. So this 7 told us that I was going to move 7 places to the right. So let's look at what happens when we have really small numbers now. So if I have really small numbers, it's going to be a little bit different. With small numbers, I'm going to have a negative exponent. So if the exponent is negative, then you move the decimal to the left. Think about it as you're making the number smaller. Okay? So if I have the number 6.84 times 10 to the negative 4th, we're going to start with looking at where our decimal point is. We have a negative 4. That means we're going to move our decimal place 4 places to the left. So 1, 2, 3, 4. We're going to fill in zeros in those blanks there. And put my new decimal there. So I'd have 0.000684 would be the number that is equal to. Hopefully that's making sense. So this is when we use these rules when we're going from scientific notation to standard notation. Okay, standard notation is the way that you normally write out a number. So we're going to try a couple here. 1.7 times 10 to the negative second. 8.45 times 10 to the fourth. 7 times 10 to the negative second. And 6.3 times 10 to the negative fifth. Okay, take a minute and try. I will explain them to you when you're done. So for the first one here, if we move our decimal place 2 places to the left, 1, 2, my new decimal will be here, meaning I have to fill in 1 place. So it's going to be 0.017 would be my answer. For this one, I need to move my decimal place 4 places to the right because it's a positive 4. So 1, 2, 3, 4. So I would have 8, 4, 5, and now I have 2 places to add my 0. The next one, 7 times 10 to the negative second. In standard notation, that would mean my decimal point is after the 7 here. I'm moving to make it a smaller number, so I'm moving it to the left 2 places. So I would have 0.07 as my answer. And the last one, 6.3 times 10 to the negative fifth. If it's to the negative fifth, I'm moving to the left 5 places. 1, 2, 3, 4, 5. My decimal point. When I fill in my zeros here, that's 4 zeros that I'm filling in. So 0.4 zeros and a 6, 3. So hopefully that's making some sense to you. I'd like to now talk about when we're going the opposite direction, from standard notation to scientific notation. Standard to scientific notation. So remember that if we have a positive exponent, we're talking about a really large number. So a number like 6,200,000 is a number that, when we make it into scientific notation, is going to have a positive exponent. And it's going to have a positive exponent because it's a number that's greater than 1. Okay. So I know my exponent is going to be positive, so I know it's going to be times 10 to some positive number. Well, let's look at what the positive number is going to be. So here are the steps. Number 1, you place the decimal after the first non-zero digit. So what that means is that you're going to have one number before the decimal place, and that number cannot be a 0. So here, if we have 6.2, so we want to move the decimal point to this location between the 6 and the 2. So how many places do we have to move it? Well, right now our decimal point's at the end, so we move it 1, 2, 3, 4, 5, 6. Okay, so we're going to have 6.2 times 10 to the 6th power. So we placed the decimal point after the first non-zero digit was the first step. My second step, when I did that, was write times 10 after it. Then you're going to figure out how many places were moved. Okay, so you're figuring out how many decimal places you had to move. Okay. Then we're going to write our exponent. The exponent is going to be the number of places moved. So it's the number of places moved. And it's going to be positive for a number bigger than 1. I'm sorry, a number that is a whole number. And it's going to be negative if it's a number that is a decimal number. So we're going to practice a few of these now. So the first thing that I'm going to have to do is write a few up on the board. I'll guide you through 1 or 2, and then you'll be on your own to try another couple. So I have 0.14. First thing I'm going to do is I'm going to move my decimal to between the 1 and the 4, because that is where the place where I would have one non-zero digit in front of the decimal. So I'm going to move this to 1.4. Now I think, how many places did I move my decimal? I moved the decimal 1 place, and I moved it to the right. Okay. So since I moved it to the right, I think, well, I need it to be 1 for my exponent. And I look and I see that the number I started with was a decimal number. It was not a whole number. So because of that, I'm going to make this a negative 1 there. My next example. Oops, rewrite that. Okay. So 1,400,000. This is a number that's a whole number, right? Only a whole number. And even if this had a decimal part, it's still greater than 1. So I'm going to make sure it has a positive exponent. So I know it's going to be times 10 to some positive number. To make it so that I have 1 digit in front of the decimal, I need to move my decimal between the 1 and the 4. So my decimal is going to go between that 1 and the 4 there. So I'm going to have 1.4 times 10. So I look at where my decimal originally was, and that's at the end of the number. I move it over 1, 2, 3, 4, 5, 6. So it's going to be 1.4 times 10 to the 6th in scientific notation. I'm going to give you a few to try on your own. Please write these down, stop the video, and go ahead and do those. When you're done, I'll go through the answers with you. The first one is 0.022. The next one is 443. And the last one I'm going to give you is 0.012. Please write those in scientific notation. Okay, let's see how you did. So right here, my new decimal point would go between the 2 2's, so 2.2. And it would be times 10. And I moved 2 places to get there. Notice that this number is less than 1 to begin with, which means I have a negative exponent. So 2.2 times 10 to the negative 2nd. For my second example, my decimal point's originally at the end of the number after the 3. We're going to move it so that there's 1 digit in front of it. So I'm moving it between the 2 4's. Okay. So it's going to be 4.43 times 10. And how many places did I move it? I moved it 2 numbers to the left. it's a 2 there, and it's positive because this is a number that's greater than 1. Lastly, I have this number here. I want 1 digit in front of my decimal, so my new decimal is going to go between the 1 and the 2. If I write that out, 1.2 times 10, my exponent then is going to have to go 2 places because I had to move 2 places to get to my new location for my decimal. So it's 2, and since this number was less than 1 to begin with, I'm going to make that a negative 2. So 1.2 times 10 to the negative 2. Okay, so at this point, if you have not done your supplement handout on scientific notation, please take your supplement out and do that at this time. So that was back from week 2, which we never got to, and the supplement was, it looked like this. So it said powers of 10 and scientific notation, and the back page of it too. So again, this is the salmon colored supplement. We're going to do one more part to this first part of class for Monday. And in this part, I'm going to talk about potential and kinetic energy. So I know that in your science notes, you took notes on potential and kinetic energy. You took notes in a diagram like this, right? Where you had your kinetic only and your potential only, and then an overlap. And we've talked about this briefly in class as well, that potential energy is stored energy, and kinetic energy is energy of motion. So you should be pretty familiar with that by this point in time. What we're going to look at right now is how to calculate both kinetic and potential energy. So in your problem set, you dealt with potential energy. We're going to be dealing with today gravitational potential energy. Gravitational potential energy equals mass times the factor g, which g talks about the acceleration due to gravity, okay, times the height. So we shorten that to GPE equals mass times g times h. And these letters written right next to each other mean you multiply. So when we're doing this, the mass is always going to be measured in kilograms. We're not going to worry about the unit on g, although it's newtons per kilogram. And for h, we measure in meters. Okay? So our answer, potential energy and kinetic energy, both are measured in joules, which we can use J as our symbol for joules. So at any point in time, our gravitational energy, potential energy, and potential kinetic energy should be the same. So if an object originally has a potential energy of 500 joules, it will always have 500 joules of energy, just some of it will be stored and some of it will be being used in motion. So what we're going to do is we're going to look at some different situations and calculate the potential energy. So this is on a handout that you have that looks like this, that says answer the questions about gravitational potential energy and kinetic energy. Okay. So the first question says a toy car has a mass of 5 kilograms. So I'm going to go ahead and write my notes on that one. Mass is 5 kilograms. And it says it is 5 meters off the ground. So I know that meters refers to height. So I might in my notes, circle meters and put an H above it for height. Or I might write it this way. 5 meters is height. We want to know what the potential energy is. So the formula for potential energy is mass, I'm just going to abbreviate it, mass times gravity times height. Okay? The constant for gravity is always 9.8, so we're going to make sure we substitute 9.8 for gravity. So if I'm going to find my potential energy, what I'm going to do is I'm going to take the mass. So 5 times 9.8 times the height, which is 5. Now, it doesn't matter what order I multiply in. So I'm going to choose to do my 5 times 5 first to get 25. So then I have 25 times 9.8. This is just a multiplication with a decimal problem at this point. 25 times 9.8. 5 times 8 is 40. Put down the 0, carry the 4. 8 times 2 is 16, plus 4 is 20. Now we're moving over to the 9, so I put down a 0 as a placeholder. 9 times 5 is 45. Put down the 5, carry the 4. 9 times 2 is 18. 18 plus 4 is 22. When I add these up, let's see what we get. 0 plus 0 is 0. 0 plus 5 is 5. 2 plus 2 is 4. And 2. So we have 2,450. And what's our unit for potential energy? That's right, joules for a J. So that would be my answer for the first part. Okay. Now, for the second part, they have us working with kinetic energy. So let's look at the kinetic energy. The formula for kinetic energy equals 1/2 mass times velocity squared. So the V stands for velocity, and velocity is basically your rate or your speed, and we measure that in meters per second. Mass, we measure in kilograms. And we don't need the constant due to gravity. Remember, G equals 9.8, but you don't need that for your kinetic. So now for kinetic energy, let's do the second problem. So the second problem refers to the first problem. So someone pushes the toy car on a smooth surface and it moves at a velocity of 0.6 meters per second. So what I have here is velocity is 0.6 meters per second. I just got that out of my question. What is the kinetic energy of the car? So that's what I want to find, is this kinetic energy. But right now I only have the velocity. You probably are thinking, well, where do I get the mass from? So I'm going to look at the question before that, the one we just looked at, and it's going to tell us there what the car's mass is. So a toy car has a mass of 5 kilograms. So we're going to use that mass to solve this problem. So kinetic energy equals 1/2 times my mass, which is 5, times my velocity squared. Okay. So first thing I'm going to do is I'm going to do my 0.6 squared, because order of operations tells me I do this first. So 0.6 times 0.6. 6 times 6 is 36. Carry the 3. 6 times 0, 0 plus 3 is 3. You'll notice I have 2 decimal places, so I'm going to put my decimal in front of the 3 to have 0.36. So that's my squared here. So I'm going to rewrite this. KE equals 1/2 5 times 0.36. Now some of you are probably wondering what's going on with the 1/2. But if you think about it, 1/2 is equal as a decimal to 0.5, right? Half a dollar is 50 cents. That's what we're looking at here. So I'm going to do 0.5 times 5 times 0.36. I'm going to come over here and do that math for you. So I'm probably going to just multiply 0.5 times 5 next to make that work a little bit better. So 0.5 times 5 gives me 25. Put down the 5, carry the 2. 5 times 0 is 0, plus 2 is 2. And we have 1 decimal point. Okay. So now I have to take this 2.5 that I get and multiply it times my 0.36. So remember, in multiplication, it doesn't matter if you line up your numbers or not because you count decimal places. So here we go. 6 times 5 is 30. Put down the 0, carry the 3. 6 times 2 is 12, plus 3 is 15. I'm going to put a placeholding 0 since I'm moving over to the 3. 3 times 5 is 15. Put down the 5, carry the 1. 3 times 2 is 6, plus 1 is 7. And I'm going to add these. And I get 900. However, I do not yet have my decimal place in there, right? So if I look here, there's 2 decimal places in the 0.36, and there's 1 in the 2.5. So I need 3 in my answer. So that means that my answer would be 0.9. And if you remember the units of kinetic energy, the energy of motion, it would be 0.9 joules. So I'm going to give you some time now to work through the rest of the questions on this page and to check your answers. The key is on Canvas, so please make sure that you check your answers. The key is on week 4 of Canvas. Then please take a break, and we will continue after break.